Welcome everybody to the video that we will be doing under the Edu-Malanga tutorial videos channel. This video is for Matric mathematics, patterns, sequences and series, and more specifically we are looking at arithmetic sequences. This is the second video, so there is a previous video where we introduced arithmetic sequences. We derived an arithmetic sequence and we defined them, and then we derived the general term of an arithmetic sequence, and at the end of the video we did a very easy example of arithmetic sequences. In this video we will continue on the work that we did last time. We will do another example, and this example is more complicated than the one we did last time. If you're joining us for the first time, my suggestion is perhaps stay with us and see if you can follow. If you are able to follow because you do have a basic understanding, then great. But if you don't understand arithmetic sequences and you find yourself getting lost during this video, then I would suggest that you do go back and watch the previous one in order to gain understanding, and then come back to these examples and join us. So the example that we will do today, let's just call it example 1, because we'll do one more example and then we'll wrap up arithmetic sequence, is a sequence that looks like this. 2y plus 3, then the second term is 4y plus 2, the third term 6y plus 1, and the last term we will just write is 8y. Oof. Apologies for my handwriting, what a mess. Anyway, you get the picture. This is the sequence that we will be working with today. And if you recall from last time, when we did arithmetic sequences, we derived the general term. And the general term for an arithmetic sequence looks like this. We have Tn is equal to A plus n minus 1 times D. Okay, this is how it looks. N is the term number, and that's why it goes with Tn, term number. So that denotes the term number. It's always positive and it's always a whole number. The mathematical word for whole numbers is integer, if you want to sound very smart and know it. So Tn denotes the term number. This is A, this is the first term of the sequence. This is again term number minus 1, and then D is the common difference. Arithmetic sequences have a common difference because you add things in order to create the next term. Again, if you need to refresh your memory on all of this, or you're seeing it for the first time and you're a bit confused, I suggest you go and look at the previous tutorial video. It will help you understand it very well. So for our example, if we continue on, let's start tackling questions. The first question we'll tackle is, what's A? What's the first term? Just from having looked at the general equation, what's A? And for this sequence that we are looking at, A is the first term. You just have to read it, that's all. 2y plus 3. So A is equal to 2y plus 3. Easy enough, right? Then the next question, looking at the general term, we've got A, is what's D? What's the common difference? D. And to find the common difference, what you do is you have to subtract the previous term from the current term, and you have to do this for more than one set of terms in the sequence, just so that you're sure that you haven't made a mistake. So let's start off with the first two terms. We're gonna have 4y plus 2 minus, put brackets, 2y plus 3. The brackets are very important because the minus sign is going to essentially be distributed into each and every term, because 2y plus 3 is one term. It's not two distinct terms. So Please always remember to put in brackets. And then the next thing that happens is we're going to distribute the negative sign. As I've said, we get 4y plus 2. The negative sign makes this minus 2y and minus 3. And if we group like terms for this expression, we have 4y minus 2y. That gives us 2y. And then we have plus 2 minus 3. That means you have negative 3 and you add 2 to it, and then in the end you're left with negative 1. So that's what seems to be the common difference when we look at the first two terms. Let's check and confirm our answer by using the last two terms as well. So we're going to, for that, have 8y minus, let's see that term, 6y plus 1, yes, minus, open brackets, remember the brackets, 6y plus 1. That's going to equal to 8y minus 6y, that goes into there, minus 1 as well. And let's group like terms like we did before. We're going to get in the end 8y minus 6y, we get 2y. And then we get minus 1 because there's nothing to group with it. And my handwriting is doing very badly. Apologies for that. Then we get 2y minus 1 and another 2y minus 1. And in the end, it seems we get then d is equal to 2y minus 1. Okay, now we've derived everything that goes into the general term of the sequence. So for the specific sequence that we're looking at, the third question that we're going to answer for this sequence, the general term, we're going to use this. We've got everything that we need to derive it. We've got A and we've got D. So let's define then the general term for this specific sequence, and this simply becomes a substitution story. We give Tn is equal to, we solved for A and we said A was 2y plus 3, so we simply put in brackets because it's one term, guys, 2y plus 3. You can leave out the brackets. I prefer to have them because it allows me to, if I have a sign change or anything that happens pertaining to this whole term, I know that I must always assign the sign change to everything to do with it. So that's why I keep the brackets on. I would advise it because it makes it easier to remember and see it that way. But if you do math a little differently to me, you're welcome to leave the brackets off. Just always remember that if anything happens, it must affect this whole term together. So that was A, 2y plus 3 plus n minus 1, and we simply substitute in D, which we have defined over here, 2y minus 1. And there we have it. That's the general term of the sequence that we are looking at over here. The next question then, now that we know the general term, we can find any term within the sequence. And let's try find term, very simple enough, 7. What's term 7 of the sequence? In order to find term 7, if we come back to the general equation, you'll see that you have n. N represents the term number. What we will simply do is everywhere where we are seeing n, the variable n, we're going to put in the number 7. So what's the general equation will turn into T7 is equal to 2y plus 3 plus, anywhere where we see n over here, we're going to put 7 minus 1, and then 2y minus 1, which is our d. And that's what we're going to have. So in order to find the 7th term of the arithmetic sequence that we're looking at, we just have to solve for this. Easy peasy, right? So this is one term. I'm going to keep the brackets on again, 2y plus 3. And then what I'm going to do is I'm going to simplify the like terms here. So that's going to be plus 6 times 2y minus 1. Okay. BODMAS, brackets off. Now we do multiplication next. Okay, because there's no division. Yes. That's T7 again, still. That's what it is. Yes. So we have multiplication, and we're simply going to have T7. That's going to stay the same. 2y plus 3. And then the 6 is going to now multiply in. So we're going to have 6 times 2. That's going to give us 12y. And then we're going to have 6 times minus 1. And that's going to give us minus 6. Okay. Then we can remove the brackets. And because we also have addition, we just put the like terms together. We're going to have 2y plus 12y. That's going to give us 14y. And then we're going to have the 3 minus 6. Essentially what we do is we say negative 6 plus a positive 3. That moves us up to, we end up at negative 3. So term 7 of the arithmetic sequence that we are looking at is 14y minus 3. Easy enough to solve, guys, right? Okay. The next question, which is the fourth one we'll be answering, is which... Now it's slightly different. It's not very complicated. We can do it. Which term number is equal to 22y minus 7? So yes. So it's different because in the last question we had the number, we had the 7, then we came up with the term. Now we're changing and we have the final answer, and we are trying to solve for n. Okay, let's start off by rewriting the general term of this sequence so that we can understand it. So the general term, just to refresh our minds, is Tn is equal to 2y plus 3 plus n1 minus 1, 2y minus 1. So we're going to rewrite it. Tn is equal to, open brackets, 2y plus 3 plus n minus 1 times 2y minus 1. Okay, and we're solving for n. We have the final answer that we need over here. And essentially, n is the term number, right, guys? But we also need to realize that once you put the t and the n together, it essentially becomes a term. And so Tn is equal to this. So in order to solve, what we do is we substitute in this instead of Tn, and then we solve for the n because we're solving for the term number n. And this equation will then look like 22y minus 7 should equal to 2y plus 3 plus n minus 1 times 2y minus 1. And this is the equation we simply have to solve, guys. Okay, the first thing we'll do is we will subtract the added terms. We'll do it on both sides of the equation because that's how we deal with the equations. So on this side we'll say minus 2y plus 3, brackets are very important. And on this side we'll also say minus 2y plus 3. And now you understand why I always insist that we should use the brackets. Let me continue. Okay, now you are, yes. Now you're going to understand why I insist that we use the brackets, because you've got minus 2y plus 3. You've got the minus essentially subtracting into everything and into everything within the brackets. And this is how it affects your mathematics. So on the side of the equation, you have 22y minus 7. 22y minus 7. And then you have subtracted minus 2y. Essentially, the minus sign must be distributed into the negative, and minus 3 as well. If we had forgotten brackets, say for example, we would have minus 2y plus 3, and we would be wrong. So that's why I insist and I encourage us to keep the brackets on. On this side of the equation, what happens is the 2y minus 3 is going to cancel because it gets subtracted out, and you get left with n minus 1 times 2y minus 1. Let's group like terms now. We have 22y minus 2y. We get 20y and we get minus 7 and minus 3, that is minus 10, should equal to, open brackets, n minus 1, open brackets, 2y minus 1. Okay, and because we're solving for n, we're trying to isolate the n, so the next thing we do is we divide everything by 2y minus 1. On this side we do the same as well, we divide by 2y minus 1. On this side it's going to cancel out, and on this side we have to divide. It's a bit complicated dividing expressions like this. For me, I just find it complicated because, say for example, I was just looking at 2y divided by 20y, easy peasy, I say the y's cancel. But because you have like essentially like a single term that can go wholly into that term, because those are two single terms, you have to divide every part of this expression with every part of this expression. And how I do it, which is very much simplified, is I look at each term in isolation. I don't add them or multiply them with each other, I just isolate them. So each like term as well, guys. So the terms, for example, that have y, I just look at them and I say, if I say 20 divided by 2y, 20y, sorry, yes, divided by 2y, I get 10 at the end. Okay, so that's the one term that I get. If I say now negative 1, don't ignore the sign, divided by negative 10, then I get negative divided by negative is positive, then I get 10. So everything individually seems to divide and get you 10. So they are actually joined one into a singular term. It's actually one term. They're not individuals. That would mean that 20y minus 10 divided by 2y minus 1 is actually equal to 10 then, should equal to n minus 1. And to solve for n, we simply say 10 plus 1, because we add, right? Oh, yes, that's the other way we can do equations. We can move this to that side. If you use that method of moving things to the other side, you always need to remember to change signs. Every time something moves to either side of the equation, it changes signs. So if we move the minus 1 to this side of the equation, it becomes a plus 1 is equal to n, and therefore we get n is equal to 11. And you have solved that question. The last question that we will look at for this sequence, and then we'll put it to bed and rest, is number 6, question 6, I believe, and it's very much simply does the term 56y minus 24 belong in the sequence. How we find out that terms belong in the sequence, oh, my handwriting is a mess, sorry. How we find out that terms belong in the sequence is pretty much the same as what we did in the previous example. We need to substitute in and solve for n, but we always have to remember the special restriction that goes with n, with that n must always be a positive whole number. Guys, this is important. When you're solving for n, you find that your n is like a fraction. So you find 2.5 or like 3.6, anything that has a point, then you know that this term over here doesn't belong in the sequence, because for sequences and series, you always have n being a positive whole number. There's no fractions that go with it. So we're simply going to do what we did for the previous example. We're going to solve for n, and depending on how n looks, we'll know whether 56y minus 24 belongs in the sequence. So let's get started then. Let's rewrite our general equation just for interest's sake. Our general equation is Tn is equal to brackets 2y plus 3 plus n minus 1 times the common difference, which is 2y minus 1. So we're trying to figure out if 56y minus 24 belongs in the sequence. We're simply going to substitute it for Tn like we did. 56y minus 24 is equal to 2y plus 3 brackets, guys, I insist on the brackets, plus n minus 1 times 2y minus 1. Okay, again we're going to subtract minus 2y plus 3 on both sides of the equation, minus 2y plus 3. The equation will then become 56y minus 24 minus 2y and minus 3, because the negative sign is going to be distributed into this term and into that term, giving us negatives everywhere. This is important to remember, guys, because math will always work like that. These are just some of the rules that never change. Should equal to, on this side, this is going to cancel out because it gets subtracted. And then we're going to be left with n minus 1 and 2y minus 1. Okay, my handwriting is improving. Great. So we group like terms, 56y minus 2y, we get 54y minus 24 and minus 3 combined, added together, that gives us minus 27, should equal to n minus 1 brackets 2y minus 1. Okay, because we're solving for n, we're going to divide everything by 2y minus 1, and we're going to do that on this side as well, 2y minus 1. Okay, on this side these two are going to cancel out, so we're left with n minus 1. On this side now we have to do the math, and it simply becomes, let me rewrite it, 54y minus 27 divided by 2y minus 1 should equal to n minus 1. Okay, the methodology that we discussed last time, let's look at that. Isolate all the like terms. So negative 1, negative 27, that gives us 27. 54 and divided by 2y, that gives us 27 as well. So if this is a single term and this is a single term, that means that 54y minus 27 divided by 2y minus 1 is equal to 27, should equal to n minus 1, and therefore n is equal to 27 plus 1. All I've done was move the 1 to that side and change the sign of it, and n is equal to 28. So the answer to the question is yes. That the term 54y minus 27 does belong in the sequence, and it's equal to term number 28. That's simply how we solve it. If we had found that n is equal to 28.3, then we were going to be like, no. So just always keep that in mind, that if when you get asked a question regarding whether or not a term belongs in the sequence, they're testing you on your understanding of what n should be, as well as how you're able to manipulate the equations to get to a final answer and understand what n is. Thank you very much for staying with us, and we'll do one more video on these kinds of series.